Hello. Today I will present our paper identifying the correlation between language distance and cross-lingual transfer in a multilingual representation space, which I have worked on with my colleagues from Philippy, Siwen and Shohreh Haddadan. Cross-lingual transfer is especially useful when it comes to improving the downstream task performance for low-resource languages, for which only limited or no labeled data at all is available. Typically, cross-lingual transfer involves three different steps, where the first one would be to pre-train a multilingual model, such as multilingual BERT or XLM BERTA, then to fine-tune this model on labeled data in a source language, which is usually a high-resource language, and then to evaluate it on a target language, which is most commonly a low-resource language. This can be done in a zero or few-shot setting. However, it is known that different factors can impact how well this transfer from one language to the other works, where language similarity has definitely been shown to be one of the most important factors, which is also what we focused on in our paper. However, we were interested in seeing how this impact translates onto a representation space level. We performed a correlation analysis where we wanted to investigate the relationship between three different variables, which would be first the cross-lingual transfer performance that we measured using the typical zero-shot cross-lingual transfer pipeline that I mentioned before, where we use natural language inference as our evaluation task and use the XNLI dataset where we use all 15 languages as source and target languages. Secondly, the impact on the representation space, which we measured by comparing the representation space of a given language before and after fine-tuning, using the centered kernel alignment method. And lastly, language distance, which we quantify using the lang2vec tool and the URL-logical database. The first observation was that all language distance metrics correlate with cross-lingual transfer performance, which was not a surprising result, but rather confirms past research. After that, we also observed that cross-lingual transfer performance indeed correlates with the impact on the representation space, which means that the more the representation space of a target language is impacted, the better the transfer to that language works, and vice versa. This correlation is generally a bit stronger in the deeper layers than the earlier layers. And then, lastly and probably most interestingly, we did observe some correlations between the impact on the representation space and language distance. These correlations have not been the same for all language distance metrics, as we could for example see a strong correlation for genetic distance, but only moderate correlations for the geographic and syntactic distance, which tend to be more significant in the deeper layers of the model. For inventory and phonological distance, almost no correlation was observed across all layers. However, a general observation is in other words that at least for some of the language distance metrics, that the more linguistically similar source and target language are, the bigger the impact on the target language's representation space is. So now, after having made these observations, we asked ourselves if we could somehow use these findings to improve the transfer to linguistically distant languages. So an intuitive idea was, for example, to freeze layers that show a significant correlation between language distance and the impact on the representation space, as the shifts that happen in these layers might potentially be responsible for the transfer gap between distant languages. Therefore, we performed three simple experiments to test our hypothesis. Across the different experiments, we select different layers that show a significant correlation between language distance and representation space impact. At the same time, we compare the correlations between language distance and cross-lingual transfer performance, where a higher correlation means a higher transfer gap. In our first experiment, for example, we froze the second layer, which showed a high correlation between the representation space impact and inventory features. And indeed, we were able to decrease the correlation strength between inventory distance and cross-lingual transfer performance, while the average transfer performance across all target languages remained more or less similar compared to the full model tuning. In our second experiment, for demonstration purposes, we selected a layer that shows a positive correlation between the representation space impact and phonological distance. And indeed, by freezing this layer, the transfer gap increased. In our last experiment, we chose three different layers at which the representation space impact correlates with different language distance metrics. By freezing them, the transfer gap could be decreased across all three language distance metrics, while the average transfer performance again remained comparable to the full model tuning. In conclusion, our paper offers a new perspective on the representation space dynamics during cross-lingual transfer, as we did not focus on the relative impact on the representation space, meaning the cross-lingual alignment, but on the absolute impact on the representation space of a given language. While doing this, we observed an intercorrelation between language distance, representation space impact, and transfer performance. Using these observations, we came up with a hypothesis which would allow us to reduce the transfer gap by making it possible to target specific languages that differ linguistically from the source language, we performed 3 small experiments that aim at proving the validity of our hypothesis. Even if these experiments only provide limited evidence, we hope that more large-scale experiments investigating our hypothesis will follow in the future. Thank you.